Okay, welcome to Module 3. Today we're going to be talking about Chapter 6, which is going to be focusing on ionic and molecular compounds. So one of the reasons that we want to use this is because pharm techs, they work under the supervisions of a pharmacist, and their main responsibility is to fill the prescriptions by preparing pharmaceutical medications. And they also have to obtain the proper medical medication and calculate, measure, and label the patient's medication. And you guys have been doing awesome with the different calculations, so I know that you will do fantastic with these as well. So looking into some of the definitions and what we're going to need to know to apply it to these questions. Ions specifically are the transfer of electrons. And so atoms form positively charged ions when they lose electrons and negatively charged ions when they gain electrons. Because remember, they have charges, right? So if you lose one, you're going to end up losing a negative charge, so you're going to end up positive, or if you gain one, you're gaining a negative charge. And then ionic bonds are formed between the strong attractive forces and between the positive and the negative ions. And so we're going to learn and then build upon for this whole module how to write the symbols for the simple ions of the representative elements. Okay. So specifically talking about ionic and covalent bonds, chemical bonds are formed when atoms, again, lose, gain, or share valence electrons to acquire an octet of 8 valence electrons. And this is called the octet rule. Well, if you guys remember Octomom, she had like 8 kids, right? So octo, octet, that's 8. And so remember that that second shell, or the second orbital, is going to have 8 electrons, right? So this kind of plays in with that. So the two definitions here for you guys to remember are that ionic bonds occur when the atoms of one element lose the valence electrons and the atoms of the other element gain those electrons, where the covalent bonds occur when they're sharing. Okay, so ionic bonds, it's like it's me, I, and I'm taking it all. Where covalent, they're going to be sharing the electrons, and specifically, this is going to attain a noble gas arrangement. So looking at an example of this one, do you see how the ionic bond, again, is completely transferring because it's I, me, mine, right? So the ionic bond is complete transfer, where the covalent bond, they're overlapping, so they're playing nice together and they're going to be sharing them. M is a metal and NM is a non-metal, just for the key for these as well. So looking at positive ions, these metals are going to lose or donate those electrons. And those metals in group 1A, group 2A, and group 3A, they have low ionizing energies, and so they're readily going to lose one or more of their valence electrons to form ions with a positive charge. They lose the electrons until they have the same number of valence electrons as the nearest noble gases. And so, like, if you look at the periodic table of elements, right? So, let's see if I'm in here. The ones like the noble gases and stuff, the ones over here, they tend to donate the ions because they like to, everyone tries to be like at an even keel. And if these guys are only having like 1 or 2 electrons, it's very easy for them to just donate them and then do that sharing thing. Where these guys over here, they tend to be a little greedy and grab onto them and gain them. Okay. So, again, those metals in group 1A, 2A, 3A, they're going to readily donate or lose those electrons to, therefore, then when we have that, lose that the negative charge, they will end up with a positive charge. And they're going to try to have a full orbital just for stability. Okay. Um, so an example of a sodium ion in group 1A, they're neutral with 11 electrons and 11 protons. So they're going to lose 1 electron to have the same number of valence electrons as neon and a filled energy level. And so they're going to form an ion with 10 electrons and 11 protons. And therefore, since they lost one, they're going to have an ionic charge of +1. And so this is why, for instance, sodium is always labeled or written as Na+, okay? Because they're going to donate that one. You can see that down here. So, yep, Na+, and then their loss of the valence electrons, right? And that's how you end up getting the sharing, okay? Or the loss, I'm sorry, not sharing. Specifically talking about magnesium, These guys are neutral. They have 12 electrons and 12 protons. And so because of this, they're going to lose those 2 electrons so that they can be more stable. And then they'll have the same number of valence electrons as neons, and they have a filled orbital or energy level. And so they form an ion with 10 electrons and 12 protons and an ionic charge of +2. So again, that's why you're going to see magnesium is +2. So you might want to like make a little flashcard of these guys, because I know when I was going through getting ready for, lecture on Tuesday for this semester, um, it was like, oh crap, which ones were +2, which ones were +1. So, it might be a little good thing to write. I'm actually trying to find an ink pen. I'm in my office and I have like a gazillion here, but I can't find my favorite one. And you know me, I have my little favorite ones, but I guess this little guy is gonna work. Okay, so we're gonna write Na plus because that's 1. And then we're gonna write Mg +2 because that one is going to be 2. Like I said, this is just a cheat sheet. You don't have to do this, but I know that going on to do the problems like that we're going to do in our live lecture, it will be helpful to have these around, unless you guys have a fantastic memory, which I know you do because you're amazing. Okay, so when we're talking now about our nonmetals and our negative ions, these ones are going to gain those electrons. So the group 5A, 6A, and 7A, these are going to have ionizing energies, and they're readily going to gain 1 or more valence electrons to form ions with a negative charge in an ionic compound. And so they gain those electrons until they have the same number of valence electrons as the nearest noble gas, and usually that's 8. So again, we're just trying to fill our shells to be happy, okay? And so, since the electrons are going to have a negative charge, when you gain an electron, you're going to end up having a negative charge, where the other ones we lost it, so we have positive. So an example would be chlorine in atoms in group 7A are neutral. They have 17 electrons and 17 protons, and they're going to gain 1 electron to have the same number of valence electrons as argon, and therefore have a filled energy level. So to form an ion with 18 electrons and 17 protons, that means that we're going to have an ionic charge of -1, and so that's why we write chlorine as Cl minus, because we lose or we gain an extra negative charge. So then we're going to have the -1 there. Okay. So here are some formulas for our common names and common ions. Okay, so again, this might be the cheat sheet that you can print out instead of doing chicken scratch little notes that I have, but what else works for you? Okay, so this is the formula names, ions. So the ones that are going to be adding a single charge are going to be lithium, sodium, and potassium. Those that are adding 2 are going to be magnesium, calcium, and barium. And then aluminum here is a special guy, and he actually adds on 3. Okay, so he's written as Al plus 3 or 3 plus, right? And then these guys are going to be the nonmetals that lose them, all right? And so nitride are going to lose 3. Phosphide are going to lose 3. Oxide and sulfide are losing 2, where fluoride, chloride, bromine, and iodine are only losing 1. Okay. So we're almost to the end in the study check. Okay, so again, this is just another way to visualize those things. So we can use the group numbers in the periodic table to determine the charges for the ions of the representative elements. And so we have our noble gases, right? And we have the metals that lose valence electrons, either 1, 2, or 3. And so this is like it says, the examples of monoatomic ions and their nearest noble gases. And so you can see that the nearest noble gas for lithium is going to be helium. For sodium, magnesium, and aluminum is going to be Ne. Okay, so you can see this is again another fun table, and it tells you how many you're going to lose or gain. Okay. Why do we care? Well, this is because ions are important in regulating body functions. And so in AMP, more than likely AMP2, you talked about the sodium potassium ATP ACE pump and like muscle contractions. We get to talk about that a little bit more like in the second part of this semester. But why do we care? Well, for instance, sodium, this is the principal cation outside of the cell, and its function is to regulate the control of body fluids. And where do we get it? From salt, cheese, and pickles, my favorite food group ever. All right, potassium. This is a principal cation outside of the cell. It helps to regulate body fluids and cellular functions. We get it from bananas, potatoes, orange juice, and milk. Calcium. It's outside of the cell, found in bones. It is a major cation in the bones, and it's needed for muscle contractions. And we get this from milk, yogurt, cheese, greens, spinach, legumes, things like that. And then also magnesium is found outside the bones, and it's essential for certain enzymes, muscles, and nerve control. And where do we find those? In our leafy greens, so the chlorophyll, nuts, and grains. Okay, so it is important because we actually use these a lot, and we need them to essentially function. So take a second and solve this question. We're going to write the formula and symbol of an ion with 16 protons and 18 electrons. Okay, so pause me. All right, so an element with 16 protons is going to be sulfur. Okay, so if you look at your fun little periodic table and you look for 16, where's my hand? Anyway, you can see. There we are. Good. That's the one that has 16 protons in its sulfur. It has the symbol of S. And an ion of sulfur with 18 electrons is going to give that sulfur a charge of -2. So the sulfide ion then would be written as S minus 2. Okay. All right, pause me again. So considering the elements of calcium and chlorine, identify each as either a metal or a nonmetal. State the number of valence electrons for each. State the number of electrons that must be lost or gained for each to acquire an octet, or that happy little full radius. And then write the symbol, including the ionic charge and name of each resulting ions. So pause me and all right, so let's identify each as metal or nonmetal. Calcium is a metal, chlorine is a nonmetal. Calcium has 2 valence electrons, where chlorine has 7 valence electrons. And so calcium is going to want to lose 2 electrons to be in that happy full orbital, or called the octet, where chlorine is going to want to gain 1 to acquire that. And so writing the symbol, including its ionic charge names. So since the calcium is going to lose 2, then that means it's going to be Ca plus 2. And the chlorine is going to gain 1, so it's going to gain that negative charge, making it Cl minus. Okay, good job, you guys.